Hello, everybody. Maria Drushkova here. Greetings, my multiplication explorers. I am going to talk today about substitution fractals and about questions people asked about this topic. So one of the first prompts that I want to address is, why is it called fractal? And it's the same root as fraction or fracture. It means a part or two part. Now, the interesting thing is that fractal is not about parting the space. It's about fractal. It's about fractional dimensions. Okay, what are fractional dimensions? So we have things that are one-dimensional, like a line or a string is a good model of that. Two-dimensional, something flat, like the surface of the table, you can imagine, or a piece of paper. Of course, all objects in this world are really three-dimensional, even very thin ones. So our bodies, ourselves are three-dimensional. Everything you can hold is three-dimensional. Well, when people figured out some interesting mathematics about fractals, when they built that part of mathematics, they decided to assign fractional dimensions to some objects. For example, the shore of England has a fractional dimension of something like 1.2, and the shore of North Europe that has a lot of fjords has a fractional dimension that's higher, something like 1.5 or 1.7. So you can explore it, you can find it online, and I am going to go to the next question, which I really love. Instead of multiplying the original design by 2, my child only copied it once. Now, the reason I love it is that it's a classic in fractals and in art. It's called Droste effect, the Droste effect. After this chocolate cover, so the box of Coco had the same box on it, which also had the same box on it. And so people started to make those designs. Of course, you can make it with 2 mirrors in front of one another and take a picture of it. You can make it with software, Droste software. We linked it in today's task in Multiplication Explorers. And if you are in the Google Hangout, like I am, and you screen share your entire screen and aim it at yourself, you get this effect. So is it multiplication? It's definitely a fractal. The easiest fractal is if you just make a circle and a circle within a circle, circle within a circle, just one thing still, but it's a fractal. It is multiplication by 1, which formally is multiplication, but it's not much of it, right? It doesn't feel quite real. And so this brings me to a very good pedagogical principle. Never start a new topic from something that is too simple. In numbers, do not introduce multiplication from multiplication by 1 or by 0 or even by 2, because multiplication by 2 is like adding to itself. So, or doubling, that's too primitive. That's an extreme case. So when you introduce, when you want to talk about addition, don't start with adding 0. If you talk about functions, the function that is constant, whatever comes into your function, number 5 comes out, for example. That's my favorite number. So this is a function formally. It's called a constant function. but don't start introducing functions to students using such examples, extreme examples. So multiplication by 1 is a very special case of multiplication, and it's interesting that children do pick up on special cases. They do introduce these examples eventually or even right away. It's clever, it's refreshing. It's harder mathematics for us. So do explore it, but see that you don't see that you don't introduce such examples yourself first thing when you introduce a new topic. And that's all for today's Multiplication Explorers. Talk to you later.